Schoology every single grade, and that's the story of the evolution of Wade.
All right, BCers, I got a new lesson for you called 1-2. And we have a new problem that we have to face today. So the very first problem, A, is y equals x cubed, and that is, of course, automatically multiplication, right? X cubed times sine of x, all right? So what is a fancy word that we learned back in the integrated classes for multiplication? Anybody remember? Is anybody thinking the word product? Anybody say that at home before I wrote it on the board? Remember difference, sum, product, quotient, those fancy words? Product means multiplication. Today we're going to focus on something called the product rule. Okay, that just means the multiplication rule. So here's what we have. X cubed times sine of x. You will use the product rule when you have a variable group times another variable group, an x times an x. Both groups contain an x, all right? So this is variable times variable. So just for reference, in our very first lesson of the year, we had a polynomial that started off with 4x cubed minus 8x squared, et cetera, et cetera. So why didn't we talk about the product rule? Why did we just do what we call normal, regular derivatives? Well, 4 times x cubed, that is multiplication, but 4 is just a constant, a number, it's not an x, right? So it was a constant times a variable x cubed. It wasn't a variable times a variable, that's the difference today. Also, terms were separated by subtraction and addition, not by multiplication. So subtraction and addition allows you to do each term and take the derivative one at a time. When you have a variable times a variable, you're going to jump into the product rule, which is a major thing we're going to use a lot this year. All this stuff I'm teaching you now, you're going to do thousands of times. You're going to get very good at this. All right, I'm going to give you a very silly mnemonic device here. Ho-de-hi plus hi d-ho. That is how we're going to describe the product rule. It sounds silly, but you'll never forget it. And that's the point, right? Ho-de-hi plus hi-de-ho. Now, what the heck does this mean? All right. So D stands for derivative. All right. And let's talk about hi first. The first term, x cubed, is going to be called hi. So the first term is always hi. The second term, sine of x, is going to be called ho. So we have hi and ho. All right, hi times ho. This is really one big term because if you have multiply or divide, it's one group, it's not two groups. But we're going to do like half group hi, half group ho. So what does this mean? This means when you take the derivative, you can only take the derivative one at a time. You can't simultaneously do the x cubed derivative like we did last time and the sine of x derivative like last time and then just sandwich them next to each other. That's not allowed in calculus. If that's a plus or a minus, you can do separate derivatives, x cubed rule and sine of x rule, okay? But if it's multiply, you can only do one at a time. Ho means the ho term is going to stay the same. It's just going to be exactly what it is. Times, that is implied to be multiplication, times d-hi, the derivative of the hi term, okay? Plus, the hi term stays the same, times d-ho, derivative of the ho term. So one half of it is staying the same, the other half, you're actually taking the derivative, all right? And then they switch. That is the only way to properly take the derivative of these more complicated functions that are x times x, okay? So we're going to try that. All right, so make your choice. You can write y prime, or you can write the fancy notation dy over dx. They both mean the same thing. All right, what is the derivative? Remember, that's motion, velocity, slope. We talked about all those already. Okay, what's the derivative of x cubed times sine of x? Ho d-hi. Ho term or second term stays the same. So sine of x just stays sine of x. times d high, the derivative of the high term. What did we discuss in 1-1? What is the derivative of x cubed? 3 comes down, base x stays the same, drop it by 1. So sine of x times 3x squared. That's the first part. Plus, so we'll put a plus sign. All right, so now we need to do the second half of the formula. Of course, the formula's in the way. I ran right into it. Not anymore. All right, the second half is high d ho. So now the high term stays the same. High is x cubed times d ho. We talked about the derivative of sine of x in our first lesson. The derivative of sine of x shall always be cosine of x. All right? And that's pretty much your final answer. It's a one-step question. Okay? Now here's what a better student might actually do. This is group A. This is group B. The plus sign or a subtraction sign would separate terms in math. So we have 2 terms. The best calculus students will do this from integrated 2 and integrated 3. Find the greatest common factor, the GCF, and factor it out to the front. Remember this back in the old days? Maybe even in pre-calculus, you should have done some of it. So is there anything in common between group A and group B? This one has a sine, this one has a cosine, can't take that out. This one has an x squared, and x cubed automatically contains an x squared. So we could take an x squared out of both of these. You can't take an x cubed out of both of these because this doesn't have enough x's to take out x cubed. So I'm going to take an x squared out. I'm going to factor it out to the front. And I'm removing it from group A, and I'm taking it out of group B. Now, if x cubed has x squared taken out of it, how many x's are left? Isn't it just x to the first now? All right, what's left? I've got a 3 and a sine of x left over in group A. Why did I move the 3 to the front of the sign? Aren't numbers called coefficients, right? So that's 3 sine of x. Nobody writes sine of x 3, right? Okay, plus sign drops down to here. What's left over in the second group? X to the first, drop the 1, x times cosine x. Multiplication symbol, not necessary. And this is what your top-notch calculus students will write. And everybody in BC, you're a top-notch student. You can't get into BC without being a super math brainiac. So that's what you should be aiming for right there, okay, for the future. All right, problem B. F of x equals 2 natural log of x over cosine of x. Okay, that's a division problem. There's a fancy word for division in math. It's called quotient. Remember that for division? So big surprise, you'll be shocked by this. You'll be shocked by this. It's called the quotient rule when you have division. Okay, now, do we have an x group, a variable group, divided by another variable group? Do both groups have a variable, numerator and denominator? Yes, they both have an x. If they both have an x and it's division, you have to use the quotient rule. If you remember 1-1, actually, we did have a quotient or a division. We had a minus 5 over 2x to the 7th. I think that was like our second example, example B last time. So we had division. Why didn't I mention the quotient rule? The bottom, the denominator, had a variable. The 5 on top in the numerator doesn't have a variable, right? It's not a variable over a variable. Could you use our new quotient rule once I teach it to you on these basic problems? You could. I mean, you could also kill a mosquito with a sledgehammer. It works, but why? Why do you need that, right? It's overkill. So you don't need to do the quotient rule on any fraction, but it works. It works 100% of the time. That's the good news. But if you have a variable over a variable, an x over an x, you must use the quotient rule, unless there's some way to simplify and get out of having x on the top and the bottom, okay? So here is the quotient rule, or at least your mnemonic device to remember it. Hody high, again, and that is automatically times, of course. Hody high. Now, product went with plus in the last example. Quotient or division goes with subtraction, which is true actually all throughout math. You've already seen that in integrated 2 and 3, even integrated 1. When you have division, it's often associated with subtraction. When you have multiplication, it's often associated with addition, all right? That subtraction line is so long, it looks like a fraction bar. My gosh, Mr. Wade. Okay, Hody high minus high D ho. So it's just like the product rule except for subtraction. One more twist. The derivative of a fraction is another fraction. So that's just the numerator. There is a denominator. It's just ho squared. How about that for easy? If you want to put a y prime to remember this, by the way, you can also add that to example A. So that's your quotient rule. Okay, a good question to ask. What's high? What's ho this time? High is up high. So high is the numerator, and ho is the denominator, all right? So if you just follow the rule, Hody high minus Heidi ho over ho squared, it has a nice ring to it, you will always get the quotient rule correct, all right? And a good point to mention, you can look at the graph on your paper there. This graph is crazy. I mean, natural log divided by cosine, that function is so weird, we didn't even cover it in integrated 3. And we covered some pretty crazy functions about real life stuff. This is a pretty sophisticated function and it makes a very weird graph. Now, what you're not seeing on the graph, since I got the graph actually off of desmos.com, which is a really cool website for graphing, what they don't show is that you see the little fine line between these U shapes? They're not exactly parabolas because you can only call x squared a parabola, by the way, but they're kind of parabolic, right? What you can't see is that there are vertical asymptotes raining down the page between every U shape, separating them, so they can get infinitely close to that force field, but they can never touch it, right? So this is a really weird graph. Well, it's a really weird function, but there are functions in real life science that look like this. And we have to be able to figure out what is the steepness of that picture. Well, the derivative will tell you the steepness. So let's give it a try. Y prime equals long fraction bar. Okay, Hody high. Ho term stays the same, 3 cosine x. Doesn't change, okay? You can put it in parentheses if you want, since this is a more complex function. It's not mandatory because it's a monomial or single term. Times d high, derivative of high. Let's go to the top. What's the derivative of 2 natural log of x? And I believe this is the first time we've addressed this. A coefficient in front of a natural log or a cosine. I don't think we really talked about that yet. So when you have a coefficient, it just stays right there, okay? The derivative of 2 natural log of x, the coefficient always stays. So just keep the 2, don't even think about it, just write it down. 2 times what? Do you remember lesson 1-1? What's the derivative of natural log of x? It has its own rule. The derivative of natural log of x is 1 over the base. And wasn't the base x, okay? So natural log of x will always be 1 over x. Coefficients, they always just stay right there. Okay, subtraction in the formula. Minus high d ho. So high stays the same. High is 2 natural log of x. Extend your fraction bar a little bit if you didn't draw it long enough. Times d ho, derivative of the ho term. That's on the bottom. What's the derivative of 3 cosine of x? Okay, we just learned something about coefficients. 3 just stays. Actually, make a little space here for yourself. Put a parentheses, leave a little space because I have to talk about this too. And we'll push the 3 over a little bit. What is the derivative of 3 cosine of x? The 3 stays. You just have to address the cosine of x. What did we say was the derivative of cosine of x in lesson 1-1? The derivative of cosine of x is negative sine of x or minus sine of x. Don't put minus sine of x after the 3. If you put minus after the 3, it looks like a subtraction. That's actually not true. It's negative 3 sine of x. Almost wrote cosine again. So positive 3 cosine, its derivative is negative 3 sine of x. So you always change the sign on a cosine derivative, no pun intended, all right? That's the top, that's the numerator. Over ho squared. So the bottom, 3 cosine of x was our ho term. Squared, quantity squared, like everybody gets squared. Don't you just put a 2 on that x and then don't put parentheses. That would ruin the whole thing. Okay, boy, I'm so tempted. Kids, I want to cancel these cosines so bad I can taste it. I mean, Mr. Wade taught us all about cross cancellation, right? You, as tempting as it is, you cannot cancel these two terms because subtraction or addition prevents it. You can't chop off this piece and then just ignore these guys down here. That's not allowed in math, okay? Now, had none of this been down here, if none of this was here, you absolutely can cross cancel because look how all the terms are just multiplied up here in this section here. So if this had not been there, yes, you could have cross canceled, okay? Subtraction or addition, you can't ignore this piece over here, so don't even try. So the question becomes, what do we do? Like, you know there's got to be something. It kind of looks unfinished, and hopefully, especially like if you've had me for integrated 3 and even integrated 2, you've got these great instincts that I've implanted in your brain now where you can look at something and say, it doesn't feel finished, Mr. Wade. We got to do something, right? Okay, we can. Let's see if we can factor anything out. First, GCF. This is group A, all multiplication. This is group B, all multiplication. And then subtraction or addition is what separates groups. Is there anything in group A and group B that we could take out? Now this won't always happen, but group A has a 3. Group B has a 3. And that is not 2 natural log of x subtract 3. That is times negative 3, right? They both have a 3. I'm going to take a 3 out. Okay, is there anything else both groups have? This one has a 2. This group has a 2. Let's take that out. And they all get multiplied up front when you take out a GCF. Cosine of x, sine of x. Nope, nothing in common. 1 over x, natural log of x. Nope, nothing in common. So only 3 and 2 were shared by both groups. Okay? And again, this isn't really a half bad answer right here, but you really want to try to take out the GCF if you can. It's really going to help you later when things get crazier. So 3 and 2, factored out. Okay. What is left over from group A when I take out the 3 and the 2? There's a cosine x times 1 over x. By the way, that is cosine over 1 technically, if that helps you. Isn't cosine x times 1 just cosine x? And isn't 1 times x just x? So definitely go ahead and cram those together. Don't leave it cosine of x 1 over x. That's kind of tacky. Just make it cosine x over x. It's nice. Okay, second group, if I take out 3 and 2, 3's gone, 2's gone, they've been factored out to the front. What's left over? A natural log of x, a negative, and a sine of x. Now let's worry about the signs first. You always look at the signs first. Minus, minus. Didn't we learn in middle school that's plus? So fix that first. Don't have a double negative, right? What else is left over? Natural log of x times sine of x. Just put them side by side. Let's actually move over to the other border. We have more room here. But anyway, times sine of x over ho squared. And then there's probably just one more thing I would do here. So final answer, you know 3 times 2 is 6. Don't leave that 3 times 2. Cosine of x over x plus natural log of x times sine of x. And then one more thing. Not a bad idea to go ahead and square 3 and make it 9. And square cosine, and isn't that called, from pre-calculus, isn't that called cosine squared of x? And that's probably your best answer right there. All right? We'd probably take that one too, though. All right, so for letter C, we have division. Instantly think quotient, quotient rule. All right? high over ho. You can go ahead and just label the top and bottom. All right, how do we do the quotient rule? F prime of x equals HODI high, bottom stays the same, times d high, derivative of the numerator. Now, what did we learn in lesson 1-1? What's the derivative of 2x? Let's do an aside actually over here. All right, let's go over here and let's just look at the high term in the numerator, because you're all rookies at this. You've never done this before. So, I look at this term and I instantly in my mind just produces the derivative because I've done this for 30 years. Well, I need to get you to where you can do that. So what's the derivative? Because right now, what are we doing? We're doing d high, right? Derivative of the top. So what's the derivative of 2x to the first plus 3x to the 0 technically? Remember lesson 1? Okay, doesn't the 1 come down? 1 times 2 is 2. X stays the same. Drop the power by 1. And x to the 0, you don't even need it, do you? Okay, so that's gone. So the derivative of 2x is just 2, all right? And then the plus sign drops down. Now in the future, see, you're gonna look at this and just say, oh, I get it now. Derivative of 2x is 2. The derivative of 7x is always gonna be 7 because of the same thing. 1 comes down, right? The derivative of 98x is going to be 98. The derivative of 1048 or 44 or something x is going to be 1044. Okay, so that's always going to be consistent. And then for the 3, or 3x secretly to the 0, remember the 0 comes down, 0 times 3 is 0. And then the rest of it doesn't matter because it's just 0, right? So in the future, again, when you see a constant without an x, you're going to get really used to this. Oh, derivative of 3 is 0. Derivative of 8 is 0. Derivative of 77.2 is 0, right? All constants go to 0. So the derivative of 2x plus 3 is simply 2. That's gone. Plus nothing. So that's gone. So the derivative is just 2, all right? All right, let's put that in right here. So this was HODI high so far. Remember subtraction. Minus high. What's high? The term up top. 2x plus 3. Stays the same. Times derivative of the ho term, d ho. What's the derivative of the ho term or the denominator? 2 comes down, 2x to the first. What's the derivative of plus 2x? We just talked about that. Derivative of plus 2x is just plus 2, right? And the derivative of a constant 4 is 0, right? Okay, so that's HODI ho. So HODI high minus HODI ho over all divided by ho squared. So the original denominator, you can see it up there, quantity squared, okay? That is your derivative. Okay, if you're thinking, boy, this looks really complicated, Mr. Wade, believe me, this is the easy part of BC Calculus, all right? By the end of the week, at the latest in 2 weeks, you'll all be able to do this without even any thought. You'll just be like robots, just churning out answers, okay? Calculus robots. Okay, clean it up, right? It's a mess. All right, GCF, remember GCF? This is group A right here. This is group B down here. All right, is there anything in common between both groups? It looks like there might be. There is not. These all have plus signs, addition signs. So you can't like steal an x squared or an x or a number off of that anyway. This is a solo, this is a monomial, right? So 2, you actually could take a 2 out of this first group. You could not take an x out of this first group unless x squared, 2x, and 4, all 3 had an x, you could technically take it out. The 4 didn't have an x, that's what ruined that, okay? Only 2 could be taken out of the first group, but the second group does not have a solo 2. But Mr. Wade, I see a 2x. Well, you can't steal it off the 3, all right? You could take it out of the 2x and the 2. Technically, I think it makes it more complicated. I've got a better idea for you. This term down here is rarely going to have the same number both times. So I have a better solution for making this look nice. What we do to this in calculus is we use just old middle school skills is what we use. Okay, you've got to be really good at algebra to succeed in calculus. The 2, you can just distribute. Okay, I really want to collect like terms on the top. Remember that old phrase. But I can't right now. It's all just a mess. So if you distribute the 2, 2 times x squared is 2x squared. 2 times 2x is plus 4x. And 2 times 4 is plus 8. That is the first group, group A, separated by a subtraction sign. Okay, binomial, binomial. You can't distribute. You're going to FOIL. Remember this? First, outer, inner, last. Okay? And FOIL actually is a type of distributive property. You are just distributing the 2x to both and then the plus 3 to both. But when you see binomial, binomial, just think FOIL. 2x times 2x, 4x squared. 2x times 2 is a plus 4x. 3 times 2x is a plus 6x. And 3 times 2 is a plus 6. Okay? These boards, right? I want one long board, as all of you know who have had me before. I'll never get it, will I? Okay, over. Now, the bottom squared, let's talk about that. Don't write this, by the way. Do not write this down in your notes. Yes, we do know in math that squaring means to multiply by one's self, right? So technically, this squared is that times itself. Now, you could do a major FOIL here. It's even beyond FOIL. X squared goes to there, there, there. 2x goes to there, there, there. And then the 4 goes to there, there, there. Okay? It's like 9 maneuvers, basically. It's like super FOIL. There's no point in doing this. Please don't do this, okay? And I tell you what I don't ever want you to do. You want to give Mr. Wade a heart attack? Distribute the squared and square each term across a plus or minus sign. Don't you ever, nobody in calculus should be trying to distribute a power across subtraction and addition. That's mathematically impossible. You never do that. You have to do it with FOIL. So don't distribute powers ever across plus or minus. You could super FOIL it. There's no need to do that. There is no advantage gained in calculus. There's a disadvantage gained. You always leave the whole squared term just whole squared. You never mess with that term, ever, okay? Leave it as is, all right? So let's do one last step. Fraction bar and whole squared is going to stay whole squared, as we said. So the last thing I can do is fix the numerator. The numerator is this minus that. That subtraction sign will distribute to every term down there. But before you even do that, does anybody spy that plus 4x plus 6x? Wouldn't you just put that together? I have 4 goats, and Mr. Wade got 6 goats for his birthday. Remember that game in integrated class? And now I have 10 goats, all right? So please collect your like terms first. Now distribute the subtraction sign into that parentheses. So first group, you can actually just drop the parentheses. 2x squared plus 4x plus 8. Okay, second group, minus goes to each term. Minus 4x squared, minus 10x, and a minus 6. All right, and then the last step, you can now collect all your like terms. So this is going to be our final answer right here. Okay, I've got 2x squared, but then I lost 4x squared last night. So 2 minus 4 is negative 2x squared. Okay? I had 4 cats, but I lost 10 cats last night. Okay? Darn coyotes. Remember that one? 4x minus 10x is negative 6x. I now have negative 6 cats. All right? Darn it. And I had 8 tacos, but I lost 6 of them somewhere. I misplaced them. So now I have 2 tacos. Like terms, over ho squared. And that is a beautiful answer right there. So please be good at algebra to succeed in calculus. All right? Okay, for the last 2 questions, we're going to discuss when not to use the product rule or quotient rule. Okay, let's talk about that. And here's a classic example right here. All right, okay, COVID kids, let's see if I'm fine-tuning your brain again. Let's see if, in case you've lost a step, the first thing you do with letter D, anybody? Change the radicals into exponent form, right? We did it last time, okay? So right off the bat, base x, what root? There's nothing listed, Mr. Wade. It's not a cube root, 4th root, 5th root, then it's automatically a square root. Put a 2 on the bottom. What's the power? What power is x going to? Secretly x to the first, right? Square root of x shall always be x to the 1/2, always, okay? All right, parentheses, x minus, hey, there's another square root of x. Make it x to the 1/2, right? So always change your radicals first, okay? That already looks better. Now, is this multiplication? Yes. Anything that sits side by side in math just means multiply, right? So is this an x times another x group, right? Call this group A, this is all a group, this is group B, if you will, okay? And could you label this high and label this ho and do the product rule because it's multiplication? Yeah, you could do ho d high plus high d ho and go back to the product rule, correct. But do you have to? If you do the product rule, it's going to be a disaster. Now, unfortunately, it's a yearly tradition. Some student in the class on the first test does the product rule on this one because they see multiplication and they think, oh, product rule. And then they get this huge, awful answer that doesn't even fit in my box. And it's like, okay, there's got to be a problem here, right? And you could be one of the best calculus students in the class and still make this silly mistake and be careless. All right. If there were a power on the parentheses, this would be an awful derivative to take. You probably won't even take that if you go to Harvard or MIT. You probably won't do a derivative like that, okay? But if there were a power there, x to the 1/2 could not distribute into the parentheses because somebody put a lock on the gate. I use that analogy all the time in integrated 2 and 3. If the gate is locked and there's a lock on the parentheses, you can't distribute. But guess what? There wasn't a lock up there. Somebody left the gate unlocked. You were allowed to distribute the x to the 1/2 into the parentheses. So if you see a space or a place where you can distribute, take advantage of that. If you can't distribute, you're just going to have to do the product rule, okay? So if you can distribute, please distribute. So x to the 1/2 times x to the first. You can go ahead and put a 1 there if you wish, because I'm going to show you something. X to the 1/2 times x to the first. Minus sign drops down. Distribute x to the 1/2 times x to the 1/2. Okay, gate was unlocked. Go ahead and just walk right in. All right, how does this give us an advantage? Okay, go one more step. Don't leave it like this, because you'll still be thinking, oh, do I do a product rule here and then another product rule over here? You could, but boy, would you make a mess out of this problem. You remember, even in middle school, and definitely in integrated classes, if the base is the same and you are multiplying, isn't that addition? You remember this? Add the powers? Okay? I mean, I'm sure in middle school you did like x cubed times x squared is x to the 5th, because same base, add the powers. Okay? It's that right there. So x is the common base to the 1/2 plus 1, or shall I say 1/2 plus 2 out of 2 is 1 in disguise. 1 over 2 plus 2 over 2 is 3 over 2. Okay? Add your powers. Minus comes down. Is it the same base? Yes. If it's xy, you can't do anything. If it's xx, you can do something. Keep the base, add the powers. 1/2 plus 1/2 is 1. Or you could just actually just skip the 1 there. Okay? One more yearly tradition that somebody in the class will probably do this, and again, it could be one of the best students who's really good at calculus and they get a little careless. Mr. Wade said if there was no lock on the gate, I could distribute. Correct. I distributed, I worked all the way down to here. I'm very good at algebra. I'm gonna put this answer in the box. You're so close, but you get no credit. All you did was middle school math to get to here. What about the derivative? Did you forget the derivative? Because you were so focused on just doing all the algebra, you forgot to do the calculus. Don't forget, we still have to take the derivative. Now, if you want to Hody High plus Heidi Ho it, you could make this into a gigantic, colossal mess, as I said. Or you could take the derivative of our finalized version, our simplified version. This derivative is going to be very easy, which is why we went through all this trouble. Y prime equals, what do? Go back to 1-1, our first lesson. It's just base x to a power, base x to a power, all separated by subtraction and addition. It's just right back to the basic thing we call the power rule, okay? The derivative of x to the 3/2 is simply power to the front. Base x stays the same. Subtract 1 from the old power. Or shall we say 2 out of 2. 3/2 minus 2/2 is 1 over common denominator 2. Okay? Subtraction sign comes down. There is no product rule necessary here, even though it did begin as a multiplication problem. All right? Because it turned into a subtraction problem. What's the derivative of x to the first? The 1 comes down. X drops to the 0. Oh, wait, don't even have to put it. That's it. By the way, we did start in radical form square root of x. So technically x to the 1/2, isn't that square root of x? So overachievers, you'd be better off putting 3/2 square root of x minus 1. I'd much rather see that answer. All right, letter E should be an easy problem. But again, if you simplify it, it'll be easy. If you try to jump into some rule that I've taught you without simplifying, you're going to get a disaster, okay? And I don't want you to get that. So here's what we have. We have a number, E is a number, roughly 2.7, and it's going to the variable power, okay? And we did a rule for this. It was, I think it was like 3 to the x last time. We did a rule for number to an x, which is called exponential growth, exponential decay, right? Okay, this, you do not want to do this rule right here, all right? But that's the thing. Some people, they inadvertently do that rule. So here's what we want to do. Remember your natural logs and your e's. We did this exact problem in integrated 3, actually, okay? Identical problem in integrated 3, and you should have definitely done it in pre-calculus. E to the natural log power cancels, okay? If you're like integrated 3 basics, e to the natural log of x, e to the natural log will always cancel and you just get x. That is something you should remember from integrated 3 and from pre-calculus, okay? It's the only way out of this problem. E to natural log wants to cancel, but that darn 4 is in the way. Does anybody remember integrated 3 where the 4 was in the way, but we realized something special? Here's another thing you should know from integrated 3. You remember 2 natural log of x? You remember how the coefficient is interchangeable with the exponent, like they're the same thing? Only in log world can you put the coefficient up to a power or the power down to a coefficient. So in log world, 2 times natural log of x is actually natural log of x squared. Oh, we did that in integrated 3 so many times. We had a whole chapter on these things right here, okay? Another thing to remember from the past. So, block off that E right now. Just focus on the upstairs. I wish the 4 that we circled wasn't in the way, because if the 4 was out of the way, E and natural log are cancelable. We could move 4 out of the way because it's sitting in front of a natural log, and only logs will allow you to take that coefficient and store it up in the attic. Hide it upstairs. So we're going to store the 4 up out of the way. Okay? We got like Christmas decorations in the way. Put them in the attic, right? Not even Christmas time. Okay, so E, we're just going to keep it there. 4 is going to get stored up here as a power. So natural log x cubed, take the 4, move it up. Now here's the big question. What's going to the 4th power? Is it 3 to the 4th? Is it x cubed all to the 4th? Is it natural log of x cubed all quantity to the 4th? There are 3 options here. You better get this right. Only what we call the argument or the base, only the base goes to that power, not the log. That would completely change it mathematically if you put it around the log as well. That's something else we'll learn later. When you move the coefficient up, it's the original inside or base or argument that goes to the power. So it is x cubed quantity to the 4th, not just 3 to the 4th. But the natural log is not in there, okay? So please remember everything you ever learned in integrated 3 and pre-calculus, because guess what? We're gonna use every bit of it. Now E and natural log are side by side, unlike over here. Now you are allowed to cancel. And you get x cubed to the 4th. So the E and the natural log both completely dropped out of this problem. It actually was not an exponential growth equation. It's a polynomial. That's all it is. But we can simplify it even more before we take the derivative. X to the 3rd to the 4th. Power to a power, you multiply the powers, right? Middle school, also integrated 2 and 3. That's not x to the 3 plus 4. Don't be silly. That's x to the 3 times 4. That's x to the 12th. All right? That looks much better. You know how easy it's going to be to take the derivative of x to the 12th compared to this colossal mess over here, which you could use the exponential rule I taught you in 1-1, and you could eventually simplify like 16 steps and eventually get to the correct answer. No, make it easy on yourself. Spot the E in the natural log, okay? So I will not be taking the derivative of this. I will be taking the derivative of x to the 12th. But don't forget to take the derivative, because a lot of students, they put x to the 12th on the test. It's like, well, I'm glad you can do integrated 3. I'm trying to teach you calculus. You still haven't done the calculus. Take the derivative. So y equals x to the 12th. Y prime equals, very first lesson we did, power rule. Just take the power, bring it to the front. 12, base stays the same. X, drop it by 1. 11, that's it. There's your derivative, okay? So D and E both, when to simplify. Use your skills to simplify stuff. Because if you have strong algebraic skills, you will be able to sail through calculus, okay? And that's what we need to be able to do. When to simplify, and then A, B, and C when we could not simplify, all right? Now, try the 5 homework questions. I always keep homework short, so do all 5 questions. We will discuss the answers in class and go over anything that didn't make sense, all right? Write sine of x3. Put 3x squared. I mean, 3. And so 9 so 9 sine, dang it!